Now let's look at compound inequalities. Compound means more than one problem that we're going to put together. And there's two different types. There's an and type of problem and an or type of problem. And usually denote that they mean an intersection. So when you think of and two problems come together. They form an intersecting where they cross. They share the same values. We'll see here when we solve those problems. So typically, 9 times out of 10, the graph is going to come together. With an or problem, we want to think union. It's the union of two separate lines, or two separate problems. So as you see here, these lines are separated. One's going left towards my negative infinity, and one's going right towards my positive infinity. Okay, let's look at this type of compound inequality. Compound means I have two different questions that I'm bringing together, separated by this time an or. Or, remember union, we're going to have graphs that go separate ways. They're going to go their separate ways where we've got to count for both sides of the graph. What we want to do is solve both of these for x separately. So, 2x is greater than 10. Again, I need to get rid of this 2 being multiplied. Opposite of multiplying and dividing. Let me divide by 2. Gives me x is greater than 5. When I'm done, I've solved the left. Or, now let me solve this one. 2x minus 3 is less than 5. I need to isolate my variable, so I need to get rid of this negative 3. And what's the opposite of subtracting 3? Adding 3, because that'll make that 0. It'll give me a 2x on the left, less than 5 plus 3 is 8. Last but not least, once again, how do you get rid of a 2 being multiplied? You divide it by 2. And I have x is less than 4. So my solution is x is greater than 5 or x is less than 4. But let's see how this looks on a number line. Let me draw my number line here. Going to negative infinity to positive infinity. I have two numbers 4 and 5, so let me go write those down, 4 and 5. And I have x is greater than 5. Am I using brackets or parentheses at 5? Well, I don't see an equal sign here, so I'm going to use parentheses. And greater than means I'm going to be all values greater than 5, so I'm going this way. Also note I'm going in the direction the arrow is pointing. Now with 4, x is less than 4, I'm going to use parentheses because it's less than. I don't see an equal sign. And it's all values less than 4. Again, the arrow is pointing left. So let's see here with my or, my union, I do have two graphs that are separated. One's going left and one is going right. So ask yourself, how do you put this in interval notation? Again, interval notation just directly copies, or is the shorthanded version of my graph. So what is the far left? The far left number is negative infinity. Can we ever equal negative infinity? Nope. So I'm putting parentheses. Comma, where do I stop? I stop at 4. What do I have? I have a close parentheses. What else is next? 5. And there's a parentheses at 5. Comma, where am I going? Going all the way to infinity. Can never equal infinity, so I'm going to use parentheses. And since we're talking about or, union, I'm going to put a little u here. So my solution in interval notation is open parentheses, negative infinity, minus 4, comma 4, close parentheses, the union, open parentheses 5, comma, infinity, close parentheses. Here's how you would graph it. Here's how you would write an interval notation. And this is a more or less set builder notation form. You're just solving it to get you here. Again, we're going to focus mostly on interval notation and graphing in this class. Now, what about an and type of compound inequality? Again, I have two separate problems, and I need to solve these each separately. So let me go ahead and look at this one. 6 times x minus 2 is less than or equal to 10x. First thing I want to do, order operations, work with what's in the parentheses, and I'll need to distribute this 6 inside each. So I have 6 times x is 6x. 6 times negative 2 is negative 12. Less than or equal to 10. Oops, 10x. Now I need to move this 6x over. So what's the opposite of plus 6x minus 6x? That'll cancel. Give me a negative 12. So less than or equal to 10x minus 6x is 4x. Notice I'm not flipping the sign because I'm using subtraction here. It's not multiply or divide. Last but not least, I need to get rid of this 4 to my x. What's the opposite of multiplying by 4? Divided by 4. That'll cancel. Negative 12 over 4 is negative 3, less than or equal to x. So there's my first solution. Again, we were talking about an and type of problem. And remember, is intersection. So I want to figure out where do these two lines intersect, come together. Here, 5x is less than 10. What's the opposite of multiplying by 5? Divided by 5. Let me do that to both sides. I get x is less than 2. So my solution is x is greater than or equal to negative 3, and x is less than 2. Now how would this look like if I were to graph it? Okay, let me put my number line here. Negative infinity to positive infinity. I got two numbers, 2 and negative 3. 0 would be in the middle. Let's look at this one. X is greater than negative 3. Am I going to use parentheses or brackets? I do have an equal sign this time, so I'm going to use brackets, open brackets. And x is greater than negative 3. I know the arrow is pointing left, but note my x is on the different side than where we're used to. It's red as x is greater than negative 3, or negative 3 is less than x. So I am going this way, all values greater than negative 3. And then here, x is less than 2. I don't see an equal sign, so I'm going to use parentheses. All values less than negative 2. So it's going that way. And since x is on the left, I can assume that this arrow is pointing left, so I'm going to go all value here. And since we're talking about and, I need to talk about the intersection. Where do these two graphs come together? Well, right here, they come together at 3 and go all the way to 2. I can't account for these numbers because these numbers here work on this side, but it doesn't work for this side. I'm talking about and. What works for here and here? Not or, what works for here and here. These values won't work over here. And again, I can't account for these numbers because they won't work over here. They work here, but not and here. So the only values that work for both of these, and is what's in the middle. And if I were to put this in interval notation, again, let me look at the graph here. I see a bracket at negative 3, comma, I stop at 2, and at 2 I have parentheses. There's my solution in interval notation. So again, note and comes together, kind of forms a line here. Doesn't go its separate ways. And also the interval notation is also together. You're not separated by this union symbol. You're bounded by parentheses or brackets. So there's what an and type of problem will look like.